So today we're going to talk about conduits and raceways, and later on this week we are going to continue to basic pipe bending or conduit bending techniques. But first, let's see what we have, what we're up against as far as conduits and raceways. So what is the first sentence? Is there are many different circumstances that would require the use of conduits or raceways when running electrical wires. What's a raceway? Well, what's a conduit and what's conduit or raceway? A raceway is a way for it's a structured way of laying the wires or installing the wires, not just so it hangs from the ceiling, but it's some form of guidance for the wires. It's a physical guidance. So it could be a conduit. So in this case, conduit would be just one of the types of a raceway. Okay. And there could be cable trays, there could be other things that that we're dealing with, and we're going to go over that. All right, so again, let's read this again and see if we understand this more. There are different circumstances that require the use of conduits or raceways when running electrical wires. So basically what this one says, that when we install the electrical wires, sometimes we need to run them in conduits or raceways. Okay, what are the, oh, well, here's a challenging question. What are some of that you can think of? What would be the situations? Well, remember when we are talking about running the NMD 90? So NMD 90 says non-metallic dry up to 90 degrees. If you have, for example, that's an extreme example, if you are dealing with a steel framing instead of timber framing or wood framing, then you can't run those wires in the just on the surface mount, or you can't mount it to the surface of the timber of the inside framing, because it's steel and it's supposed to be non-metallic. But even though it's just non-metallic, it's okay if you run a conduit, metallic conduit, and you can run it in there. All right. All right, next slide here. So this is what a rigid metal conduit looks like. Well, you know what? Let me go to the third slide here first, and then we're going to come back to the second. Electrical metallic tubing, aka EMT. Quite often you're just going to refer that and hear the term that says EMT. Basically, it's a metal pipe, and it stands for electrical metallic tubing. There are some fittings associated with that, and that looks like, oh, it could be a 1/2-inch pipe. See, they just say 1/2-inch pipe. So 1/2-inch inside diameter, 1/2-inch. That's pretty much the smallest one we're dealing with. And there will be associated fittings with that. So here's a coupler if you want to extend the conduit, because they would come in 10-foot lengths. And if you have a longer run to perform, you're going to have to extend it. So here's a coupler. You insert the conduit from one side, tighten up the set screw. You insert from the other one side, tighten up the set screw. And here is a box fitting, right? Our box connector. Notice that. That's what we did last time during the lab. We have mounted 2-screw connector using something that's called a lock nut. So here's a lock nut, okay? And you take that off, put it on the other side of the box or the inside of the box. You put that thing from the front, and you can fit a pipe, or that this conduit fits right in there. So here's an EMT connector. And you can say EMT 1/2-inch connector, because I think this one, let's say this represents a 1/2-inch EMT. All right. Now, when it comes to rigid metal conduit, it's almost the same as the EMT, but it is not. It is tougher much tougher than the regular EMT. It's a galvanized, this one is made out of galvanized steel. This one is made out of something stronger. It's thicker. Plus, you can put thread on the couplings, or you can put thread on the pipe itself. I'm not sure if you can see that. If I can zoom that, there will be a thread. So there will be a pipe threading machines that you can use. These are those red things on the tripod. If you look at the next time you're in the lab, just take a look at those red things on tripods, and they have oil pans and whatnot in them. These are those pipe threading machines, and they will be used for putting on the threads. So you can cut the pipe and you can put a thread on it and you can join them. The rigid metal conduit would be used in tougher environment, and it can also be watertight. Right? The EMT, it could be pretty tight, but not watertight. All right. The other type of conduit, so that would be the metallic. So rigid metal conduit, EMT, electrical metallic conduit, and then we go. We can also use something that's called a non-metallic conduit, and here's an example of that. And of course, when you buy the non-metallic conduits, that is also associated with all kinds of different types of connectors. So whatever the system you decide to install, maybe you should study the type of connectors that are being used with the specific one, a specific raceway that you're going to be using. Right. So this is a non-metallic PVC conduit. And here's an example of a high flexibility conduit. Sometimes you need to just run some cables from one point to the other, and the straightness is not as important as the protection of those wires. And well, sometimes it is economical or even better as far as the functionality wise to use high flex. So we have some options. So far we looked at the rigid metal conduit. We have the EMT, which is the bread and butter of the conduits. Then non-metallic, some people like to use that. And in some situations it's better to use that. And here's a high flexible. So high flexible, well, you can bend and twist it in all kinds of different ways. Well, don't do it like that, because it's just a demonstration. All right. Now PVC conduit also. PVC conduits, and they come in different sizes. Next time you're in a hardware store like Rona or Home Depot or Home Hardware or whatever else it's in the local area here, take a look at some of the, just go to the electrical section and see what they have for conduits. So you're going to see they're going to have a lot of EMT. There's going to be EMT section. You're not going to see much of the rigid, although some stores will have considerable section as, but most of it you're going to see either the EMT, or you're going to see the PVC conduits, and that's a pretty interesting animal as well, because you can heat it up and bend it. You can use the pipe benders as you use for EMT, and we're going to talk about pipe benders as well. And you use a heat gun on that, and you can bend them to whatever shape you want, or you can buy, associated with that PVC, all kinds of prefabricated fittings, mounts, and whatnot, and even boxes. Right. So you have a bunch of options when it comes to installing raceways, depending on the situation and depending on the budget. Okay. Now, here is an example of flexible metal or metallic conduit. Right. So here is a PVC conduit. Here's a metal conduit. Doesn't flex. Rigid, doesn't flex. You have to bend it. Well, the non-metallic flexes, and some of the non-metallic flexes a lot. And then there's a PVC that doesn't flex. You have to bend it. And then, oops, here. And then there is a flexible metal conduit, which is basically an armored flexible conduit as well. One thing I'm going to tell you that you need to buy those extenders, and I'm not mentioning that here. If you run a longer straight, if you run a longer straight pathway or raceway, then the temperatures, high and low, going up and down, the temperatures will cause even PVC piping expand and contract. So sometimes, and next time I'm going to include that, but I just want you to know that once upon a time, you need to have that little accordion-like flexible piece that is going to compensate for expansion and contraction of the conduit. So here's a flexible metal conduit. Well, what does it look like? It's a metal armored conduit, but it's also flexible, of course, to some point. And there are some fittings associated with that. So everything has its own fittings. When you go and design a system, then at least for the first couple times, if you're not familiar with certain type of conduit system or raceway system, just go and study it. And how do you study? You can just go to the electrical supplier store and you can ask questions. And there's nothing wrong with asking questions. Those people are there to help you. And trust me, they are not going to look down on you because you are asking a question. They are happy that you're asking questions because you're the customer that wants to buy things. And if you buy things, that means profit for them. And they know that they were also uh, at some point of their life, they were also asking questions. So they are nice, beautiful, friendly people. Do not be shy, do not be timid. Go and ask questions, right? Sometimes some of the best answers of them, maybe there's some new product that's online, and quite often when I was asking questions, I still ask questions. Go, okay, what do you have for that? What do you have for that? And you know how many times I go, hey, you know what? Here's that new thing that came out. Check this out. You know, so um, well, don't be timid to ask questions in the specialty stores. Right? All right, now here's another thing. If you walk in our school, take a look around at some of the classrooms, some of the labs. You are going to see something that's called a surface mount or surface mounted raceway. Remember, raceway is a pathway for a cable. It's a guided pathway for a cable. So sometimes you're going to see something like that. What does it look like inside? Uh, there. Oh, we have skipped one. So the strut, the surface mounted raceway basically uses the strut type kind of a strut means basically like a stiff channel or strut channel raceway. Quite often you're going to see one and we have a lot of that in our school. So next time you're in your school, just take a look at around on the walls and you're going to see a lot of that all of a sudden, right? What does it look like inside? A lot of them are using dividers, and those strat types of raceways, they would have a division for the data section, and over here you can see some sort of a multi-pair cable, maybe for some intercom or whatnot. You can run data wires and or any kind of signal wires, and over here you could see a optical fiber. Usually optical fiber I would prefer to run in a separate raceway, so there is no possibility of any other thing coming down on it and accidentally damaging it, but maybe somebody decided to include that in with some other cabling as well. And over here, look, it's electrical. These are electrical wires, right? So here's actually a good example because as you go along with the electrical installations and whatnot, you're going to go over as you go along. You're going to be asked to install a lot of electrical systems, electrical panels, maybe connecting some motors, electrical motors, maybe doing some home installation, maybe performing some commercial type installation and whatnot. So that would involve a lot of electrical wires. However, you'll be surprised. how huge part of your business is going to be running data wires as well. And well, still is a pretty huge gap between the electrical systems installers and the data infrastructure installers. Somehow, the electrical installers or the electricians, they would think that they can, if they can run electrical wires, they can also run the data wires in a proper way as well. But quite often it's not the case. So what I'm trying to do for you right now to close the gap between the ability to install electrical wires and the ability to install data wires. There's certain subtle differences as far as as handling the equipment and the wiring. Um, but you will be asked, you will come across challenges that would require you to know both systems. So here's a good example. Here's a Strat Raceway. Part of it is reserved for electrical wires. Part of it is reserved for data or otherwise signal wires. Okay. And that's what it looks like when it's on the walls. So you can see, well, if you don't want it after when it's available for you to download, you're going to be able to see here is an outlet. All right, here's the duplex receptacle. So obviously the top part of that raceway is reserved for the electrical wiring. And over here, look, here's a box with maybe telephone or probably a couple of data outlets. So the bottom of that raceway will be reserved for the data. And there'll be, when you take the cover off that, you're going to see a band, like a lot of wiring in there. Right? Because the wiring comes from somewhere, and you're going to have a bunch of wires, and some of them are going to end here, but some of them are going to continue. So they're still in the initial bundle. So you know what I mean. And sometimes you're going to see those above the desktop on countertops, or you're going to see them underneath the countertops. And sometimes you're going to see them climbing on the walls, going up the ceiling. Okay. All right. Cable tray. Cable tray is it looks like well, it looks like a, not a step ladder but extension ladder or straight ladder, right? So couple of rails here, and that looks like the prongs, and basically it's installed sideways or horizontally on usually in the ceiling, hanging quite often um, from the you can see the threaded rods here. Here's a cable tray, and the threaded rods are mounted into the concrete ceiling, and um, and they are holding the cable tray. So that is when you have a lot of wiring, and quite often it is above the tiles in the ceiling, and sometimes when it does not matter the aesthetics as much, so there will be like a behind the scenes kind of rooms, and it's more convenient to have the wires exposed because you're adding and taking away, you're always working on it, so it's a good idea to have that exposed to some sort of convenience level. And cable trays you can also make from the well, you can make them, um, or you can buy them. I know, and we'll go over that. Making them from the Strat channel um, takes a little bit more time, and buying them prefabricated takes a little bit more money. Well, it comes up to the same thing, basically. You pay more money for something that's ready made, and you can mount it quickly, and in the same time you can do something else. Or you can buy a bunch of channel struts. They look like sort of like this, yeah. And you can cut them, and you can make the raceway, the cable tray out of it. So you're saving money on buying the equipment, but you're losing money on the time that you're spending in which during which you can do something else. That's when how could I put it gently? When you become the owner of the company, I want you to consider that. Or maybe, I don't want you. you might want to consider that idea, the concept that I just told you that, right? And that's all I'm going to say about that in case somebody is watching. You know who you are. All right. Love you. All right. Okay. So here is a wire way, right? Um, well, it's a modular system of cascaded sort of cases that you can open and you can join them, and that's where you run the wires. What does it look like? It looks like this. Right, here's the hinge that is open, and those are being used to run either electrical or data wires. Um, the problem with that, well, the problem first, the use of that when you need some enclosed system in some sensitive environment, or sometimes it's just required that you do that because of the aesthetics. The challenge with that is that is the problem that quite often when people service whatever the system is, you may actually be required to add some wiring from one place to another. So you're just going to run more wire in the tray from one point to another. And people have tendencies to leave or abandon the existing wires even if they are not being used. So after a while, it will look like this. It will look like filled up system here, and you don't know which wires are used and which wires are not used. So just in case you're not going to damage something that's functional and you're going to cut somebody's power off or cut somebody's signal off, then you, just in case, you are going to leave it and just keep adding them on. So my advice to that is, if you are replacing a system, please make sure you pull your wires out. So just for the reason so that that thing actually can be manageable. I have seen those wire trays, especially with the data infrastructure wiring, like Ethernet cabling, that were just filled to the brim to the point that they were just hanging out of there. You couldn't even close the hinge because of that reason. All right. Bus bar. Bus bar is a modular system. There would be pieces, prefabricated pieces with cabling inside already, and there will be connectors, like locking connectors. So you just mount them like a Lego. Um, so that's the idea of a bus bar. Now, they're also quite popular in the office furniture, so-called modular office furniture, also known as the cubicles. So quite often on the bottom of the cubicles, you will actually have included a bus bar, and some of them are built in to the cubicle or the modular furniture. So it's just basically kind of snap and lock, and that's how your wiring is being run in that, mostly that's mostly for electrical systems, and you still have to run the data part because nobody knows how many outlets and where they're going to be. So that's a bus bar. And that's the end of this presentation. Uh-oh, what did I do? I just, there we go. I lost part of my screen here. Now, what can we do here? I'm going to show you two, and they're similar. Here is one presentation, and I'm going to have this thing available for you to download. Actually, you know what? Let's just go quickly over this one, and then I'm going to go over the next one after that in a little bit more detail, because the next one is pretty much a glorified version of this one. I did this earlier, and I did the other one, but there's some elements here that are not there, and there's some elements there that are not here. All right, so EMT. Let's look at the EMT bending. So we're beginning to enter the pipe bending zone right now. All right, let's start. EMT stands for electrical metallic tubing. That's take care of some definitions. A raceway. Remember, we're talking about raceway. Raceway, sometimes referred as a raceway system, is an enclosed conduit that forms a physical pathway for electrical wiring or other wiring as well. Raceways protect wires from cables from heat, humidity, corrosion, water intrusion, and general physical threads. Right? And NEC stands for National Electrical Code. It's just some when you're going to see some of the acronyms. So that's I just decided to put that on here. All right. Here is a statement and a half. As an electrician, you will be required to install EMT as part of your job. The EMT serves as the raceway for the cabling infrastructure. Here's the thing. The pipe bending is an art of in its own rights, and it looks like it is intimidating at first, and it might take you a while to get the grasp of it, and the only way to fully get into the pipe bending is you can watch bunch of videos. You can yes, some of the videos that are all over YouTube, for example, they're going to show you some idea of how to do that, how to bend the pipes, what to pay attention to, what the multiplier is, and how to calculate the angles and the shrinkage and whatnot. But you can do that until you're blue in the face. Here's the thing. You gotta get yourself a pipe bender. And you can get one from the electrical supplier store, and you can get that one. Now you can get one at the local hardware store. There are those pipe benders, and they look like this. They look like this. I have a couple of those. These are, I took a picture of, this one is a can opener, a beer bottle opener, but it looks like that. And we have a bunch of them hanging on the wall, the real ones. So here's one by Ideal, which is in the blue color. And there's also one by Klein. Which one are you going to prefer? I got two, because I bought my personal stash. I got an Ideal 1/2 inch, and I got a Klein 1/2 inch, just to show you some of the differences between them. There are subtle differences. They operate the same but different, right? They have their own flavor. Okay, so that's a pipe bender. Unfortunately, this is a little over $100, and this is a little over $100. We have those bunch of Ideal ones hanging on our under the staircases on the wall. So you can, whenever you finish the lab quicker, you can just grab one and practice pipe bending. There's never too much practice on the pipe bending. And if you want to learn how to do that, just do it. Get scrap pieces of EMT and grab one of those and just bend away. Just go and practice, practice, practice. I can't say that enough, right? So let's just go quickly over this here. Electrical, so you will have to, want it or not, you are going to have to get good at it, right? And just be patient with yourself. It will come to you as a second nature, but you're going to have to go through some of the doing. You learn this thing by doing, for sure, right? The ability to bend conduit is a requirement for all electricians, right? And here's the example of a rigid conduit, and here's an example of some immaculate job done by somebody as far as bending conduit. So this is a true art, all right? Okay, now, basic EMT sizes. Electrical metallic tubing EMT, also commonly called as tin wall, because this wall here, that's a tin wall, all right? So that's sometimes it's called tin wall. So it's a steel raceway of circular cross section, which is unthreaded, right? So EMT is unthreaded, and normally 10-foot long. Sometimes it comes in 20-foot length pieces. However, most of the time you're going to see 10 feet long. 10 feet is probably the most you might want to throw into on top of the van or inside the van for transport. Available in sizes 1/2 inch all the way through to 4 inches. The outside is galvanized for corrosion protection, and then the inside has an approved corrosion resistance organic coating. EMT is installed by the use of set screw or compression type couplings. We'll take a look at set screw. Oh, well, here's a set screw right here. All right, that's all it is. You put that thing into the connector and you tighten it with a set screw. Compression would be, there's no set screw, but there will be a inner ring and an outer ring of the connector, and then when you tighten the ring, the connector compresses itself around the pipe. All right. EMT is installed. Okay. Reference 1, wherever that thing is. All right, trade sizes. Okay, so here's a table of the trade sizes. So what we have here, 1/2 inch, and this is the one that we're going to be working with, 1/2 inch EMT. Uh, it's very common, but sometimes even more common would be 3/4 uh, of an inch, right? So 1/2 inch and 3/4, very popular sizes for the EMT. Then you also run 1 inch, 1 1/4, 1 1/2, 2 inches, 2 1/2, 3 inches, 3 1/2, and 4. And over here you have the metric millimeters of a cross section, and here is the nominal weight per 100 feet, and here's the outside diameter. Excuse me, and there's a wall thickness, so you can study the table if you wish. All right, but if you want to concentrate on anything more than other things, concentrate on the sizes available. Yeah. And just as I said, 3/4 of an inch is probably the most popular because, well, it's not too thick and it's not too thin. And 1/2 inch is also extremely popular as far as running the conduits. Basic bands, right? This is also part of the second presentation that I have, so there's a bit of an overlap. So here's a stub up band. Stub, what's a stub? It's a right angle band. So it's a stub up band, right angle band. That's it. Then there is a back-to-back band. Sometimes you need to run the pipe here and then go around, turn around, and run it somewhere else. And that's 2 right angle, 2 stubs back to back. So it's a back-to-back band. There's an offset band. Sometimes you're going to have to change the planes of traveling. So here is a surface, and then there is maybe a little bit of a step up, maybe another wall, and you're going to have to continue on another surface, and these two will be parallel, and you're raising the plane, and you go. So it's an offset. You're offsetting the planes of the way the conduit runs. And here's the offset. This is also an offset, but this one is called a box offset. The only difference between a regular offset and a box offset is the box offset is meant for the pipe to be mounted on the electrical box. Right? Sometimes you're going to have to overcome obstacles. And here is something that's called a 3-point saddle band. So 1, 2, 3 points. Yeah? 1, 2, 3 points. Excuse me. There is a 3-point saddle band. And sometimes you're going to have to, instead of doing that, you're going to be able to create something that's called a 4-point saddle band. So 1, 2, 3, and 4. And notice that a 4-point saddle band is, well, it's just like 2 offsets back to back, but not to be confused with the back-to-back band. So you get 2 offsets opposite to each other, and you get a 4-point saddle. Of course, I'm just going to bring that to your attention that there is something that's called shrinkage involved. When you bend the pipe, when using so when you have a regular 10-foot piece, let's say from here to here it's 10 feet, and you do the bands, after doing all that bands, the distance from here to here is not going to be 10 feet, it's going to be a little bit shorter, right? Because you're losing some of the length of the total pipe for the bending. Of course you're going to. So that's considered a shrinkage, right? And there's a way to calculate that, right? Basic benders, that's what they look like. There's a regular pipe bender, here's a Hickey bender, all right? Here's an EMT bender, Hickey bender. That's what they look like. 2 different, there are other companies as well, but some of the most popular ones will be Ideal or Klein. And as you go along, you're going to make up your own preference as far as which one to use. And not only you're going to decide which ones you feel more comfortable with, you're also going to, once you get the one that you use, you're going to stick to it, because as I say always, all the tools that we use, they seem to have their own personality. There could be two same model numbers of the same tool, and one is going to behave slightly different than the other. So once you get yours, you're going to be personally attached to yours, and you'll see what I mean as you go along. Pipe bender markings. So over here you have the degree marks, the angle degree marks. When you bend the pipe, you're going to bring that to any of those markings to see, let's say maybe you want to bend it just 10 degrees, or maybe 22.5 degrees, or maybe you're going to have 30 degrees or 60 degrees or 90 degrees. All right, so depending on how far you want to bend the pipe, you're going to use those as guidance. Right, here's a star, and here's a teardrop, and here's an arrow. Teardrop, okay, so the notch used for the center of the 3-point saddle band. Here's a 3-point saddle band. All right, when you're going to make 3-point saddle band, first you're going to do this band here first. You're going to mark the pipe here, mark the pipe here, mark the pipe here accordingly, and then you're going to align the teardrop. All right, see that? The teardrop right here, right? Just a notch. You're going to align that with this mark right here, and you're going to perform your first band. So that is the teardrop. You're going to align with the center of the 3 saddle band. Okay? Then here is the star. All right, where's the star? Star used on the back-to-back bands. Here's a back-to-back band. The star will give you this distance right here. When you have a straight pipe and you make a mark and you put the star on it, it will give you this distance right here. As we go along, I'm going to show you exactly what I mean, because I can talk about it all night, and sometimes I'm going to be more and sometimes less successful in explaining things. I can spend half an hour talking about it, but it could take me about 3 minutes to show it to you. All right, so just be patient. I just want you to know that there's something like that exists, and if you want to use the back-to-back bend, you're going to use the star on that. All right, then we have the arrow used for all other bands. So when we're going to do the box offset or the offset band, we're going to align things with the star. Again, I'll show you by doing it. Now here, I have prepared some of the, I found some of the videos that could be useful for you. So to just watch those videos. They're not that long. This one is 12 minutes. This one is 9 minutes, 5 minutes. Just so you get some idea of what pipe bending is involved, what is involved with the pipe bending. Okay. So that's the last slide of this one here. Now, let me just get the other quickly. Is that the one? Yes. Okay. Definitions of, and we're going to start on this one, and we're going to continue next time we see each other. Right. So EMT bending. Here's another angle from another perspective. Right. So here's the EMT bending. Here's an example of a cline, and here's an example of the ideal. I just took a couple of pictures and put them together. And look, here's a classical example of something that's called a box offset. Right, you're offsetting the pipe, you're offsetting the planes just to accommodate the knockout that is not flush with the bottom of the box. We have to raise it a little bit. Okay. All right, EMT electrical mechanical. Okay, we have done that. This is the same thing that I was showing to you. It's just a different pictures. EMT electric made of. Okay, we already have done that on the previous things. You know, maybe we don't have to come back to it. We're just going to go straight into the multiplier. Okay. Oh, here's a bit more information here. Rigid metallic conduit and intermediate metal conduit. Rigid is a heavy-duty galvanized steel tubing installed with threaded fittings, okay, typically used in outdoor to provide protection from damage. Can also provide structural support for electrical cables, panels, and other equipment sold in 10 or 20-foot lengths. Intermediate is a thinner, lighter weight version of a rigid metal conduit. So it's something between EMT and rigid, approved for use in all the same applications as for rigid metal tubing. So because of the IMC is lighter and easier to work with than the rigid metallic conduit, it is more common in new installations. Right? So RMC, rigid metal conduit, and IMC, intermediate metal conduit. Non-electrical metallic tubing, flexible corrugated plastic tubing, moisture resistant and flame retardant, easy to bend and installs with a snap lock or glued plastic fittings. So the convenience of installation is just goes up there. Cannot be installed in exposed locations, which means exposed to elements. So it's not for outside. Commonly used inside the walls, can be installed inside it can be installed inside concrete block structures, can be covered with concrete. Due to the blue color of the common brand of this product, ENT is nicknamed as Smurf tube after the Smurf cartoon characters. Well, so there you go. RMC and IMC, we already have done that. Okay, it just went backward instead of forward. Come on. FMC, so you just touch the mouse and this thing just, all right. Flexible metal conduit and liquid tight flexible metal conduit, all right. You can read this, or I can read it and you can listen to me reading it, or you can well, there's pretty much self-explanatory description here after you download that. Here's also something that's called a rigid PVC conduit, polyvinyl chloride. I'm not going to ask you to remember that, but PVC, right? Similar to plastic plumbing type pipe, installed with plastic fittings and blah blah blah. All right. And it's we're using glue to mount that. Very popular for installing the raceways. Okay. Basic fittings, right? So you remember, here's the one with the set screw and here's the one with the compression. Set screw, here's a lock nut. You put that thread inside the box knockout and put the lock nut on the other side, tighten it, and that's it. And once you insert the pipe into this connector, you tighten it with the set screw. That's a set screw EMT connector. Here's a compression EMT connector. You undo it's a concentrical type of a spinning, twisting, turning thing. You can undo this connector by turning the gland ring. All right, so it kind of uncompresses that. You put the pipe in there and you tighten that, and it just goes with the compression. It compresses the pipe. So here's the set screw, here's a compression EMT connector. Are the differences. This is the same table that I just transferred that onto this PowerPoint. Sizes of the EMT. Right? There are the types of bands that we already studied. Here's the difference between offset band and a box offset band. A box offset band is an offset band, except it's used to mount the pipe onto a electrical, box. In our lab, when we say box offset, you're going to see the lab. We're going to make two box offsets. We're going to join two boxes, one box and the other box. Here's a box, here's a box, and you're going to have a pipe going that can rest on the surface, in the same plane as the box rests. and you're going to bring the pipe to the one box, and on the other side you're going to bring the pipe to another box, and everything has to be nice and straight and equal. It's going to take you most of the lab to accomplish that. We talked about that: 3-point saddle, 4-point saddle bands. And here's one, the new one that's not included in the previous presentation. Here's something that's called a kick. All right, so what do you have here? Here you have a stab up band, or stab, which is basically right angle band. And if you want to raise it a little bit, you just come over back a little bit from the wall, and you kick it. You don't kick it with your foot. You put it in the pipe bend there, and you just bend it slightly in order to raise that. So that's this type of bend is called a kick. Popular bend as well. Right? Conduit benders. All right. Anatomy of that. Here's the foot. Here's the handle. Here's the shoe. Here's the hook. And here's the footrest. Right? And another perspective on that, we already talked about that. Arrows, we're going to study all those, so just so you're comfortable with the way this thing is being used. I think we're going to be able to finish that. And sometimes, because of the diameter of the band radius of the shoe, if you need to make a little tight band, you won't be able to use that. So that's why something like that was invented. If you want to make a tighter band, that's called hickey band there. Okay, used for small bands with short segments. All right, ideal for, okay, so that's the last slide here. Just as a motivation for you, I would encourage you. I wonder how, to me, when I start watching that, I can't stop. Right? I just find that it says Ideal by the company Ideal, organized by Ideal, National Championship Pro, second round of parallel EMT bends. That's something I got from the found on it's happening somewhere in the States. They have pipe bending competition. I think it's quite fascinating. So I encourage you to watch that. All right. So this is it for today's class. And next time we're going to talk about some specifics that have to do with pipe bending. All right, so we're going to start. I'm going to get you to start doing some thinking until it settles you. I'm just giving you the idea, and it's going to work in your head. Then we're going to have this lab. It's the pigtails. So please watch the video for the lab preparation, and I'm going to keep throwing some ideas of pipe bending, and by the time you are done with the pigtails lab, you're going to have enough eagerness in you to actually start wanting to start grabbing the pipe bender and the pipe and bending away. All right. Okay, so that's it for today's lesson, and I'll see you whenever it's Thursday or something like that for the next lesson. And some of you are I'm going to have the pleasure of seeing in the labs. Okay, thank you guys, and have a great rest of the week. And remember, even though it's Monday, every day is almost Friday. With that happy thought, have a wonderful day.